In this problem, we're going to go through a variety of rational equations and find the oblique asymptote for each one of these. And I want to give you a hint right at the very beginning here. Don't worry, it's not as bad as it looks. There are 6 equations to find, but really we only have to work for 4 of them. And here's the reason. Oblique asymptotes come from rationals which are top-heavy. Okay, what I mean by top-heavy, we've talked about this before, that's when the exponents on top are higher than the exponents on bottom. So, for example, see this one right here? This is equal weight. It has an x squared on top and an x squared on bottom, which means there is no oblique asymptote. And if you scan through the rest of these, you'll see, what do we have? X squared over x, that's top heavy. X squared over x cubed over x squared, right? These are all top heavy. And I want to point out this last one. X cubed over x, that is also top heavy, but it does not produce an oblique asymptote. Because to have an oblique asymptote, you have to have top exponent exactly 1 higher than the bottom. Now take a look at this one again. That x cubed is 2 powers higher than the x on the bottom. That means it's not going to produce an oblique asymptote. It would actually produce a quadratic asymptote, which we are not going to get into. Those are just terrible things. So this is a DNE. Okay, so we have 2 DNEs, very different reasons why they don't exist. But what we really have to deal with is just these 4 other equations. So let's start with this one right here. I'm going to find the oblique asymptote for this equation right here. And what I'm going to do is set up synthetic division. Right, -2 comes from the bottom. 8, 10, and -3 are the coefficients from the top. So you just work through your synthetic division. You should be fast at this by now. Okay, we don't need to worry about the remainder column. It's just 8x minus 6. Okay, so that's y equals, don't forget the y equals 8x minus 6. All right, and that is it. So let's do another example. This one looks complicated, right? Because it's got an x cubed in it, x squared. And the reason I'm going to jump to this one is because it's actually a little less complicated than this guy right here. So let's do the x cubed one next. I want to factor it. Before I go anywhere, I want to factor this guy. And I'm not talking about the top, because I don't know how that factors. We would need to use rational roots theorem for that. And I am sparing you any rational roots problems in this unit. But the bottom is very easy to factor. It's x minus 4 and x plus 3. So when I do synthetic division on this, I need to do 2 sets of synthetic division. One for the x minus 4 and one for the x minus 3. So let's just start with the x minus 4. The coefficients from the top are 1, 3, -2, and 5. Go through your synthetic division. You get 7, it's 28, adds up to 26. We don't need to worry about the remainder. Okay, do another synthetic division. Now it's -3, 1, -3, 4, and we don't need to worry about the remainder column. So we just get y equals x plus 4 for our answer there. Now, there's another method of doing this. You don't have to do 2 rounds of synthetic division. You could also do long division with polynomials. And we may have mentioned that in class. I prefer synthetic division, even when I have to double it up, like in this one. Because long division just gets a little messier, and synthetic division really does everything you need to. So let's just stick with one method. What is this? Old notes. Let's get rid of these. And I'm going to do that last example right here. Let's grab this guy and bring him down here. I ran out of room. Oh, wonderful. Okay, I'll just write it down. So, what is this last one? This is y equals 2x squared minus 9x minus 5, all divided by 4x plus 3. So it's more synthetic division. But what you have to do with this one is deal with fractions. Now, the 4x plus 3, let's do that first. 4x plus 3 equals 0. That means 4x equals -3. That means x equals -3/4. Okay, that is the root. And that's going to go over here, -3/4. And the coefficients from the top we put up here just like normal. Okay, and now we go through our synthetic division. This is negative 3 halves. Negative 3 halves minus 9, negative 21 halves. And it helps if you're good with common denominators. But if you're not, you can go ahead and write that out. See why negative 9 plus negative 3 halves is negative 21 halves. And we don't have to worry about the remainder column. So, is this our answer? Right, this is a question. Is our answer y equals 2 minus 21 halves? 2x minus 21 halves? No, it's not. The reason is we haven't divided by that coefficient in front of the denominator, that 4 right there. We have to divide everything by that thing. So that is y equals 1/4 times 2x minus 21 halves. And this, honestly, is the hardest thing that you have to deal with in synthetic division. Remembering that coefficient in the front needs to be divided by. And we've been over the reasons for that in other videos. I won't rehash them here. But if you want this in simplified form, this is just going to be, well, let's see, 1/4 times 2 is 1/2. So it'll be 1/2 x minus 21/8. Okay, so that was our last solution to this one.